All right, so we're going to get started today with exercise 212, which is fundamentally working on your assignment 202. It's kind of it's building on what we did last class. We'll get a little bit more specific with it. First, I'm going to talk about your assignment 202, which is handed out here. A couple things to note. First one is that your file, your AutoCAD file that is ready for laser cutting should be done and turned in on March 18th. So that's a week from today, a week from Wednesday. So you should be able to get to that point. The reason that I have a separate date for the digital file being due from the actual cut being due is because I'm forcing you to have that done, and then you have a couple weeks to cut, or a week to cut. So the other thing is, because of the way that spring break falls this semester, the physical model isn't due until after spring break, and I don't like having things due on Monday after spring break because that just ruins your spring break. So it's due on Wednesday after spring break. So it's kind of a long time until this is done. It also means that when you guys get your assignment 203, 202 and 203 are kind of, they end up being done close together. So it's just the way the cards fall this particular semester. So we're going to work through this over the next 2 days so you have a pretty good idea of what we're making. Essentially what we're making is a cardboard model of terrain. And I have several of these that people have left behind that I'll pass around. We're going to concentrate today on basically building the terrain, figuring out what the step interval should be, what the contour should be, and then starting to draw the steps on the side. Next class, I'll go all the way through the process again, so you'll see it start to finish. But we'll concentrate on kind of building out the sides and getting ready for the actual laser cutting, doing the scale, etc. So I have enough of these so that you guys can all kind of pass it around and take a look at them. I've found over time that it helps for people to just kind of have a physical one to reference as you're looking at it, because what we're building makes more sense when you see it physically. So that's assignment 202 in a nutshell. Today in exercise 212, we're going to start with this whole process. So like I said, each time I go through this, I'm going to repeat from start to beginning. So I'll start all the way back at SketchUp, which is what you guys did last class as well. So there's a little bit of repetition. I would encourage all of you to actually start fresh today, though. Going forward, between today and Wednesday, you don't need to start fresh again. You'll just pick up where you left off at the end of class today. So I'm going to start fresh in SketchUp. Again, I would encourage you not to pick terrain that's too steep. So don't go pick Half Dome or something in Yosemite because it's just too steep. You're not going to be able to cut this. We want a reasonable undulation, not a sharp cliff. If you do something with too sharp of a cliff, it ends up being too many little pieces and too easy to burn up in the laser cutter. So something a little bit more moderate is generally pretty good. So in SketchUp, I already have SketchUp Pro 2019 open. I'm going to go to the File menu, and I'll choose Geolocation and then Add Location. And hopefully this doesn't happen for everybody. This has been my day-to-day. Yep, so the network's down. Great, so convenient. So I can't do that and get the geolocation. So the good news is I can use my geolocation from last time. But unfortunately, I can't show you that in SketchUp. Luckily, I also have Rhino already open, so I'll be able to start on this. Not everybody probably has Rhino open, so you have to wait for the network to come back. Sorry about that. So first thing I'll do is I'll bring in that terrain from SketchUp. So I'm going to go to File and then Import. I'm not doing Insert. Insert would be a block reference. Import is just bring the actual raw terrain data straight in. Let me go to my flash drive. And this was my terrain from last class. Oops, wrong one. Yeah, that was the wrong one. All right, let me try that one more time. File, Import. I accidentally picked the Rhino 3D model, so instead I want the SketchUp model. There we go. The SketchUp import options, the defaults here are just fine. We're going to go ahead and say OK. And that brings in my SketchUp model. There it is. So when I start working with my SketchUp model here, the first thing I want to do is look at my layers and kind of adjust my layers. So I have the terrain itself. I'm going to switch into shaded mode so we can see this better. And I'll move that onto layer 5 and call that SketchUp. So let me take that, right click, and put it on the SketchUp layer. This SketchUp plane, I probably should create a sublayer for that. Change object layer. And then I can go ahead and delete the original SketchUp layers like that. So I'm left with my piece of SketchUp terrain. And now I need to convert this over into that NURBS mesh surface, or excuse me, just the NURBS surface. So I'm going to do a contour X and a contour Y, just like we did last class. I'm going to change layer 1 to be contour X. I'll change layer 2 to be contour Y. And then I'll make layer X, contour X active. And we're going to slice this mesh up using the contour command. So it's curve, curve from objects, contour. Alternatively, I could type contour into the command line. I need to turn on my vertex snap here so that I can actually snap to that corner. And I'm going to go ahead and go out in this direction, but I want to be, I'll turn ortho on so I'm going directly in line with my axes, not up or down. And then my distance between the contours will be 100 feet. And it will then slice up that piece of terrain. If I were to turn off the SketchUp terrain, we'd see all of those slices. The gaps in here are due to that OpenGL error, so let me turn that off. We go to Tools and then Options, View, OpenGL, and uncheck the tessellation. There we go. Now we can see it as a straight set of lines. I can confirm that I did it correctly by looking down on it in the top view, and all of those lines should be perfectly horizontal, which they are. Let me jump back into the perspective view here, turn back on my SketchUp terrain, and with nothing selected, I'm going to go back to my curve, curve from objects, contour. Select objects to contour. It's going to be that mesh again. There it is. I'll press enter. I'll snap again to this corner. Oh, you know what? I didn't change my layer. There we go. Now I'm on contour Y, and let me go off in the Y direction here. Actually, it's in the negative X, but that's okay. And my distance between is going to be 100 feet. And now that is sliced up as well. Let me turn off my SketchUp. And we can see what's left is just a network of curves that I've created. So in order to use the curve network command, like we did last class, I need to clean up the edges so I don't have any ragged edges along the outside. So I'll go ahead and go into the top view, and I'll use this curve. I'm going to hold down Shift. I'll use that curve, and that curve as my trims. Then we'll go ahead and type in trim, and we'll trim off all those pieces, trim off all that. Oops. There we go. Trim this section here, and then trim the bottom. I do want to make sure that I get in nice and tight here and get all of those last little bits. Perfect. I'll go ahead and press enter to end my trim. And now I have a network of curves that is completely contained. There's no ragged edges to it. And this I can then convert over into a curve network, an actual surface. Before I do that, I always like to save because it's possible that this crashes. I'll go to File and then Save. Let's put it into today's folder. Go ahead and click on Save. Excellent. Now it's time to convert this over into that curved network. So I'm going to select, maybe not. I'm going to go ahead and select all of those curves. I'm going to go up to surface, curve network. Alternatively, I could type in network SRF as the command line. Yes, I want to continue with these 115 curves. And if I did it correctly, I should receive an A, B, C, and D on the 4 sides of this particular piece, which is good. I have to wait for the little dialog box to pop up here, so we'll hurry up and wait. There we go. I'll go ahead and just say OK, and it will then go through and build this curve network for me. So I'll go ahead and pause the recording. We'll let it finish. It could take a couple minutes. Hopefully the network has come back for those of you that are still waiting for it, and we'll go from there. All right, so I appear to have gotten there. When I get the curve network to finish, I'm going to do a single click on this surface and wait for a second so that it can select the surface. There you go. It turns solid yellow when I go to select it. And then I'll go ahead and type the rebuild command. It's also available under edit and then rebuild. And I'm going to rebuild this surface at a minimum of 200 by 200. There we go. So my U and V spans to be 200 by 200. If you want to smooth it out a little bit more, we explored that option last class with the different levels. So 150 might be about the right level of smoothness for me, knowing what I did last class. So I'll do it at 150 by 150. I'll say OK. And that then makes it much more workable. So I can enlarge the view here so that I can see it. I don't need the curves, the X and the Y curves anymore, so I'll turn off the contour X. Let me take the surface and put it on its own layer. And I'll also make that surface black so you can see it. And then we will turn off the contour Y as well. So this is the resulting surface that I'm going to work with. So this surface, I now need to figure out how to make it into one of these models. So this is where we differ a little bit from last class. We got to this point last class, but now we're going to spend a little bit more time really fine-tuning what we do at this stage. So the model that I'm asking you to build is 11 by 17, which is what this is. Fits nicely on the laser cutter. The laser cutter bed's 12 by 24, so 11 by 17 fits nicely within it. We're going to build this size. So the first thing we need to know is we need to know what is 11 inches by 17 inches at the scale that we intend to build the model at. And so there's a lot of math involved in kind of figuring that out, which of course you could do, but I gave you on the bottom of the handout today this little cheat sheet that helps you kind of sort things out. So we're looking right here under paper size 11 by 17. And we're also looking here under the select scale, drawing inches versus actual feet. So for example, if we were doing 1 to 200 scale or 1 to 250 scale or 1 to 500 scale, at those various scales, our 11 by 17 model would be, let's do 1 to 250 here for example, 2,750 feet by 4,250 feet. Does that make sense? So I'm multiplying the scale out to figure out how big this is in full size. So you're going to pick whatever scale seems good to you. And you can kind of see how they run their way down here depending on what your paper size is and or what your scale would be. This is always going to either be given to you, hey, I want a model at 16th scale or whatever, depending on your lot size, or it's something where you're going to have to determine it. We're kind of reverse engineering it because I want a model that's 11 by 17, and I really don't care what the scale ends up being. It can be any scale. For our purposes. So I'm going to go ahead and pick the, well, let's do the 1 to 250 for right now. And so at 1 to 250, I'll come over here and I'll pay attention to the 11 by 17. This was 4,250 by 2,750. So given that information, I'll come back to my Rhino, and I like to do this in the top view because it seems to make a little bit more sense. I'm going to create a basic rectangle corner to corner. I'll click, and then I'm going to type in the @ sign followed by 4,250 feet, and then comma 2,750 feet. I believe that was correct. We'll double check. 4,250, 2,750. Notice that in Rhino, I made sure that I put the foot marks so that I'm in the feet unit. I'll go ahead and press enter, and that then gives me this rectangle. This rectangle is representative of that 11 by 17 inches at 1 to 250 scale. So if I didn't like that scale, I could pick a different scale. I could come back to my little cheat sheet here. There we go. I could do 128th to 1, and that would be 4,008 by 2,176. So same thing, I could come back in here. I could say at 1408 feet, comma 20, what was it? 2176. 176 feet. There we go. And I'll press enter, and that would be that size, or that scale. So at this point, it's just a matter of lining these up over the top of my terrain to get the piece of the terrain that looks interesting to you. Right? So maybe something like that. If it's the smaller one, if it's this one, I might move that in a different location. Maybe that belongs more back over here. Again, it doesn't matter the scale. I'm just trying to show you how this would work. Does that make sense so far? So I'm reverse engineering this size of the rectangle. I'm going to use the big rectangle versus the small rectangle. Now once I have the size and I have it positioned approximately where I want it positioned, you may even find that doing the positioning in the top view with it turned to shaded can be kind of helpful. You can see where the hills are. Again, it's up to you. I'm going to do a project command in the top view to take this flat rectangle and have it project down onto the surface itself. So we'll make sure I'm in the top view. I'll go ahead and type project, or go to curve from objects, project. Select curves and points to project. There would be my curve. I'll press enter. Select surfaces. That would be my surface, and I'll press enter. Now as soon as I do that, that rectangle that I started with gets pushed out to the surface itself. That will then allow me to use it as a trim. So I'll go ahead and type trim, and I can trim off that extra surface around it. So now the remaining surface right here is the part of this terrain that will end up being the model. So I've now cut it down to 11 by 17 in scaled up form. And so now I have that as my terrain. So that'll be my model. From here, I need to figure out how to slice up this model. And that slice is not going to be an arbitrary value like last class. Remember I told you we did it at, I think, 10 feet last class? This is now, the slices that we're going to do vertically is going to be based on the thickness of the material that we're going to build our model out of. So if I jump back over here to my little cheat sheet here, you see that I have contour material thickness. So ranging from a 1/16 all the way up to a 1/2 inch. So you could do it out of, say, 1/2 inch plywood and have this work just as well. We're going to use the cardboard that's available at the bookstore. It's just standard brown cardboard, this stuff. We're going to use that stuff to make our contours. And if you were to measure this very, very carefully, it's a little bit larger than 1/8 of an inch, which puts us over into the 5/32. By the time you add a little bit of glue, we're almost spot on 5/32 of an inch at our contour interval. So we're going to use 5/32 of an inch as our material thickness, and we'll come down here to match up with our scale. So I did it at 1 to 250. My contour material thickness at 5/32 gives me an interval for my contour of 39.063 feet. So when I go to cut this up, I'm going to use 39.063. If I had done my 128th of an inch equals 1 foot scale, I would come over here and my contour thickness would be 20 feet at that scale. So it's going to vary depending on what scale you pick. So since I picked the 1 to 250, it was up here at, what was it, 39.063 feet. So knowing that number, I'm going to come back over into my Rhino file here. I'm going to create a new layer. That new layer will make it active, and I will call this, oh, sorry, I have to finish my trim. There we go. I will call this, I don't know, topography. Okay, so that's active. I'm going to create a contour from this surface, so I'll go up to Curve, Curve from Objects, Contour. Select Objects to Contour. It's going to be that surface. I'll press Enter. Select the base point. It's going to be on the corner right there. I need to turn on my end snap to be able to snap to it. There it is. Oops, I didn't quite get it. Let's try that one more time. There's the contour. There's my corner. Now I want the direction perpendicular to the contour planes to be going straight up and down. So I'll do that using one of the side views, either the front or the right side view. And we have it going straight up and down. There it is. And now the distance between contours was that value right here, the 39.063 feet. Make sure you type in the foot mark here. So it's going to be a distance of 39.063 feet. And I'll go ahead and press Enter. It's now going to slice up that piece of topography into intervals that ultimately are the correct thickness for making this out of it. Does that make sense how I translated that all the way through? Okay, so it's based on the physical model that you're going to make after the fact. Okay, so now I have this. I can actually turn off the surface itself, and I can work with just these contour lines, right like that. So at this point, we need to start working on the step intervals that go up and down each side. And if you look at one of these pieces that have come around, you can kind of see where I'm going with this. If you look at the side here, you see those steps. That's essentially what we're going to draw on the computer screen right now. So there's two different methods of doing this, some of which are easier. One appears easier initially. The other one is easier once you get it and have practiced with it. So I'm going to show you both strategies as you go through this, and you can choose which one you want to use. The first one that I'm going to do is I'm going to create a point on the end of every one of these curves going up the side. And I could do it on any one of these sides. I'll do it on this side because it's pretty consistent all the way here. So I'm going to come over to my tools. I'm going to click the little triangle next to this point because I don't want a single point. I want to be able to create multiple points. So it's the next one over. I'll create multiple points. It's going to ask me the location of the point, and I will do that by just snapping to the end of each of these. So I'll click on the end of each of these little curves as I go down. There and there. So I have a point on every one of those ends. And this one, oops, that one got off a little bit. There we go. So I'm going to go ahead with all those points, and I'm going to select them. Now I can use a key command to help me out here. If I type SELPT, it will select all the points, which makes my life a little easier. Otherwise, I would have to go in and I would have to select them all like this. This one, something's off with this. It's probably because it's on the back, not on the side. So I'm going to deselect that one because it's not relevant for our steps. All right, there we go. So I have all those points selected. I'm going to use a rotate 3D. So I'll go to transform and then rotate 3D. And I'll pick wherever the low point is. So these 2 points are at the lowest point. So I'll start from this point right here. I will go out along the axis, so not snapping to anything. I will go straight up, and I will fold all those points down and over to the side. So I folded those points down to the side, and now I can actually start to draw between them. So I'll start with my polyline tool. I'm going to turn on my point snap as well as my perpendicular. I'll start at the first point. I'll go down and snap to perpendicular. I'll go to the next one, snap to perpendicular. I'll go to the next one, snap to perpendicular, and work my way past all of these. Okay, so I got to this point. Now, this is at the very bottom of a valley, so I need to still go down here, but I don't know how far because I have nothing to snap to reference to, except that I do know how far because I know what the interval is supposed to be. It's 39.063 feet. I'll come over, and then I'll start going back up on this side. Come on. There it is. And I'll finish right there. So what I was able to create is this stair-step pattern. If we look at it from the side here, yep, looks like a nice stair-step pattern. Everything is at right angles to each other. Nothing's off or skewed, so that's good. At this point, I can take all of that right here, and I can use a rotate 3D and repeat the rotation so that we go from being flat back up into the vertical position. If I did it correctly, we'll see all the steps nice and even going down and then back up. So that's one method for doing it. And I think initially that method will seem easier because it's pretty intuitive. You just take your points, you rotate them flat, you draw your line, call it a day. Now the other thing that I'd like to introduce today is a more advanced concept, but it's a very powerful one once you kind of grasp it, but it's a little bit harder to get. And that is the idea that we can create a drawing plane, a plane in which we draw. And by default, this plane is flat on the ground. But we can move that plane to be vertical, and we can move wherever it is. So it's called the C-plane. And I'm going to move it. So that you can see it a little bit better, I'm actually going to make this grid bigger. So that is representative of the C-plane, but I want to make that a little bit bigger. I'm going to right-click on the grid snap icons, and I'll go to Settings. And I'm going to change my minor grid line spacing to be every 12 inches instead of every 1 inch. And when I do that and say OK, my grid's going to get a little bit bigger. I could make it even bigger than that. For illustration purposes, I could say let's make it 2000. And now you can kind of see that in a much bigger context. Okay, so this is representative of the drawing plane. So if I just started to draw something, it would always be flat on that plane. Now I can move that plane, which is what I'm going to do right now. I'm going to go to this little downward facing triangle, and I'll go to Set C-plane, and I'm going to choose 3 points. So you see that I now have that green and red axes. I'm going to snap to the first point here down at the bottom, and then I'll place one of the axes going right along here. And my second axis, I'm going to want it to go straight up and down. So I'll move into the side view and make sure I'm choosing straight up and down, like that. And we can now see that that grid, the drawing plane, moves to be in line with that side of my terrain. That means that if I were to just start drawing, everything that I'm going to draw is always going to be in that plane. So I've shifted what plane I'm drawing in. That also means that it's much easier now to start drawing from here and doing my snaps. So I can draw directly on the side without doing the rotate 3D and draw every one of my little steps. Now the other part about the this C-plane is that in order to get it back or to change C-planes to, say, the other side, you're going to want to reset it. So I'll go back to the downward facing triangle, go to set C-plane, and choose world top. It goes back to the default. So it's back to the default, and then go to another C-plane. Don't try to move from one C-plane to another. Go back to world top and then move from there. It'll just make your life a little bit easier. So once again, it would be that downward facing triangle, set C-plane, 3 points. I'll start at that point this time. We'll go along this axis, and then we'll go straight up and down like that, and that then shifts that C-plane to be vertical. Question?
So under that edit C-plane thing, there was also world right and world front or something?
Correct, correct. Those are the C-planes that are used in the front and right side view. If I were to use that C-plane here, let me show you here. Let me go to set C-plane. We're going to go back to my world top. And then if I go to set C-plane and I use world right, for example, it will set it up in a vertical manner, but it lines up at 0, 0, not at where my point is. So when I move it to my point, then I'm drawing in that plane, which makes it a lot easier. So I'm going to go back to my set C-plane. We're going to go to world top, and then I can go back to set C-plane, and we'll go to my 3 points. I'll start there again. I'll go straight up and down there, and then I can continue drawing with my steps from here. So it's the same snap strategy, and we'll work our way up. Now when I get to the top of a hill, which I'm about to do, oh, maybe not. Do I not hit one here? No, I don't. I thought I was getting to the top of the hill. I'll do one. I'll end that there. I'll do this one across the front to help illustrate this, or this one would work. I'll do this side. So I'm going to go back to set C-plane, world top. We'll go back to set C-plane, 3 points. We'll start right there. And then we'll go vertical right there. Now it's in the front. And so I'll start from that point there. So I'll initially be going down. There. Next one is there. Next one is there. Now on this level, right, same thing that happened over here. I get to the bottom of a valley. So I actually need to go down by 39.063 feet over, and then start going back up the hillside. The reason you can tell that this is the case is because this contour line comes around and ends up connecting back to there. So it's one level. And if you look at one of these models, this is, of course, not the one to look at. There's only a tiny little one. But some of them have it where you can really see where that same scenario would happen. So I'll work my way up. Now when I get to this point, we're at the top of a hill, not at the bottom anymore. So instead of going up again, I just go straight across. And then we start our way back down. So the bottom of the valley, you're going to measure and go the extra thickness of a contour. The top, you're just going to go straight across. And it should make sense from a step standpoint when you hit these various options. All right, here I am at the bottom again, so we'll go straight down 39.063 feet. We'll go across to hit there, and we'll work our way back up to there. I don't want you today to worry about the corners. You notice that I just skipped the corner. We'll come back next class and we'll deal with the corners. So our goal would be to have all 4 of the side steps done today. So you work your way all the way through from the SketchUp terrain to having all 4 of the sides with all the steps done. Next class, we'll deal with the corners. We'll look it over and make sure that they go up and down at the right places. And then we'll deal with making them into the model with the sides and that sort of thing. Okay? So I'm going to let you guys all start. I should point out that all of these are written out. There's tutorials for this stuff. If you go to the Rhino tutorial section, oh, excuse me, it's under physical modeling. Topography method 1 will walk you through exactly what I was talking about. There is also a discussion of C-plane, so you could go to that link, which doesn't exist. I'll fix that link. It would be available here as well. Let's see here. Seaplanes 5.36 would be seaplanes. And this walks you through seaplanes, etc. Okay, so all of that's there for you. We're not dealing with the physical modeling, the topography method 2. That's an entirely different strategy for how you create this. We're not going to be building that way. Okay, so don't worry about that. We're going to concentrate on just the topography method 1. Okay, so I'll let you guys start working. Let me know if you have any questions. And like I said, next class in 213, we'll start at the beginning and go all the way through again. So you'll see this at least one more time.